Aldehyde and ketone have lower boiling point than corresponding alcohols. First I will give you a detailed answer, then a statement answer. Boiling point depends on intermolecular force, and the strongest intermolecular force is hydrogen bond, okay? Then only dipole-dipole interaction is coming. So if the intermolecular force is greater, boiling point is greater, and dipole-dipole interaction comes only after hydrogen bond in case of what? Intermolecular force. That 2 points you keep in mind when I explain this answer. Okay, so see, we have two aldehyde molecules here, and you can see oxygen is highly electronegative, right? So what will happen? See, the electrons between carbon and oxygen shift towards the oxygen, become partially negative, partially positive. Same thing happen here, right? Okay, now both aldehyde molecules are acting as what? Dipoles. So dipole-dipole interaction is there, right? Okay, same thing happen here, right? Oxygen will be partially negative, carbon partially positive, right? Now between two ketone molecules also what you can see? Dipole-dipole interaction, right? Now we can check about alcohol. Alcohol, you can see oxygen is partially negative, hydrogen is partially positive, right? Same here. Now you can see what? See, between two alcohol molecules, you can see what? Hydrogen bond, right? Which is one of the strongest intermolecular force, correct? So in between alcohol molecules, you can see hydrogen bond. So more boiling point than aldehyde and ketone, where you can only see what? Dipole-dipole interaction. Hope you understand this detailed answer, right? And here is the statement answer for you, okay? Yes, aldehydes and ketones have lower boiling point than alcohol because they cannot form hydrogen bond with each other. Why? Alcohols can, due to the presence of an OH group. Hydrogen bonding in alcohol leads to stronger intermolecular forces, resulting in higher boiling points.